In topic 1, we're going to be looking at mixed radicals and entire radicals, and we're going to look at how to switch between each form to the other. So let's start off with talking about entire radicals. So an entire radical has the entire number underneath the radical sign. So remember, the radical sign is the little check mark thing, and the entire number is underneath it, as you can see in these examples here. Whereas a mixed radical has the radical sign, but we have a number out front multiplying the radical sign. Therefore, it is a mix of numbers, one out front of the radical sign and then one underneath the radical sign. So you can see in all these examples here. So now let's look at the multiplication property of radicals. So what this property is that if you have two numbers being multiplied underneath the radical sign, we can actually write them separately like this. So for instance, if we have in example 1 here, we have 16 times 9 being multiplied underneath that radical sign. Well, we can actually rewrite it as the square root of 16 times the square root of 9. Like that, we can separate them. Now remember, there is an invisible little 2 here. So if there's no number written in this spot, that means there is an invisible 2. That is the square root. So now that we separated it like this, we can actually continue solving it. We know the square root of 16 is 4, and we know the square root of 9 is 3. So this actually turns into 4 times 3, which is 12. So that is our answer for this one. Let's look at the next one here. Same thing applies, except this time we are dealing with the cube root of these numbers. So let's split these up. We have the cube root of 8 times the cube root of 27. We know the cube root of 8 is 2 because 2 times 2 times 2 is 8. And we know the cube root of 27 is 3. And now we can just multiply 2 times 3 and get 6. So now let's look at simplifying square roots. So we can use this property we just learned up here, this multiplication property of radicals, to simplify roots. Simplifying a radical means changing it from an entire radical to a mixed radical. So when we're simplifying, we want to get it to a mixed radical. So in example 2 here, I gave you 3 different entire radicals, and we need to simplify them by converting them to a mixed radical. So let's see how we do this. So how we approach these questions depends on if we're taking the square root, remember there's an invisible 2 there, the cube root, or the fourth root, and so on. It could be the fifth root, sixth root, and etc. So for example A, or example 2A, we need to approach this question by thinking of a perfect square that divides into 80. And we're thinking of a perfect square because we need to take the square root of it. So one example would be 16. 16 divides into 80, and 16 is a perfect square. So what I'm going to do is I'm going to rewrite 80 as 16 times 5, because 16 times 5 equals 80, and 16 is a perfect square. That's what we're looking for here. Perfect square. Now that we split up 80 into 16 times 5, we can now use that multiplication property. We can do the root of 16 times the square root of 5. So we know the square root of 16 is 4 because it's a perfect square. But we don't know the square root of 5, so I'm just going to keep that as the square root of 5 because we're not allowed calculators in this unit at all. And we can just rewrite this without the dot. We could just put 4 root 5. It is implied that there is a multiplication symbol in between there. And there you have it. We now converted that from an entire radical up here to a mixed radical down here. We have that number out front multiplying the radical sign. Now, there are multiple ways you can actually approach these questions, because in this first step here, there is another perfect square that divides into 80, but regardless of how you do this, you will get the same answer. So I'm just going to show you the second method that you could use here. We could have split 80 up into 4 times 20, because 4 is a perfect square. So we know we can take the square root of 4. So now let's apply that multiplication property. We would have the square root of 4 times the square root of 20. And we do know how to take the square root of 4, which is 2, and then we would have times the root of 20. Now you're probably thinking, well, that doesn't equal 4 root 5 that we have over here. However, let's look at this root 20. We can continue simplifying this. So we can still simplify this. So let's think of another perfect square that divides into 20. Well, we could split that up into 4 times 5, because 4 times 5 is 20. And then we can apply that multiplication property again. So we would have 2 times the root of 4 times the root of 5. And we know the square root of 4 is 2. So we're going to have 2 times the root of 5. And if we multiply these two together here, we get 4 root 5, which is the exact same answer as we had in the first method we used. So I'm just going to put here, same answer. So you will get the same answer no matter what perfect square you divide into the first number, but it might be a totally different process to get to that answer. So now let's look at B. So like I said, the way you do these questions depends on if you're taking the square root, cube root, or fourth root. So in this time, we're dealing with the cube root. So instead of looking for a perfect square that divides into 144, we need to look for a perfect cube. So what I'm going to do here is I'm going to rewrite our radical sign, and I need to think of a perfect cube that divides into 144. So a perfect cube that I can think of is 8, because 8 times 18 is equal to 144. And I'm just going to put here that this is a perfect cube. So now we can use that multiplication property. We have the third root of 8 times the third root of 18. I know the third root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8. And I don't know the third root of 18 without a calculator, so I'm just going to write that there. And then we can just rewrite this without the dot. And here's our final answer, 2 times the third root of 18. Finally, for C, we're dealing with a fourth root. So we need to think of a number that we could take the fourth root of that divides into 162. So let's rewrite 162 to be 81 times 2, because I know that I can take the fourth root of 81. And 81 times 2 is equal to 162. So now we're going to split this up into the fourth root of 81 times the fourth root of 2. And the fourth root of 81 is equal to 3. So we have 3 times the fourth root of 2, and that's our final answer. Moving on here, let's try some more examples. Write each radical in simplest form if possible. Sometimes there will be no possible perfect square or perfect cube that divides into this initial number here under the radical sign. So if there is no perfect square, perfect cube, or perfect fourth that divides into that number, that means we wouldn't be able to simplify it, which is why this if possible is here. So let's look at these ones. The third root of 40. So we're looking for a perfect cube that divides into 40. So let's rewrite this as, how about 8 times 5? Because 8 here is a perfect cube. So now we can split that up to be the third root of 8 times the third root of 5. And I know the third root of 8 is equal to 2, but I don't know the third root of 5 without a calculator, so we're just going to keep writing that there. And that's as far as we can go with this one, so here's that answer as a mixed radical. Next, let's look at the square root of 26. So let's think, are there any perfect squares that divide into 26? Well, perfect squares I can think of is 4. 4 doesn't divide into 26. How about 9? Does 9 divide into 26? No, it doesn't. How about 16? No, that doesn't either, and 25 definitely doesn't. So for this one, it is not possible. And the reason for that is there are no perfect squares that divide into 26. So therefore, this is in the simplest form possible already. Now let's look at the fourth root of 32. So let's think of a number that we can take the fourth root of, and one that comes to mind right away is 16. We can do 16 times 2, because 16 times 2 is equal to 32, and we can take the fourth root of 16. So now let's split that up. We're going to do the fourth root of 16 times the fourth root of 2, and the fourth root of 16 is equal to 2. But we don't know how to do the fourth root of 2 next to it, so we're just going to write that there. And here's the simplest form, 2 times the fourth root of 2. So now let's do the same thing, except in reverse. We're going to start with the mixed radical, and we're going to write it as an entire radical. So I'm just going to quickly scroll up here, and let's see what our step is in reverse. So if we're starting with this step down here, and we want to get to this step here, we need to write two numbers under those radical signs. So let's see how we can do that with example 4. So our first step is going to be writing two numbers under radical signs. So I'm just going to put these two radical signs here. And in this case, we're dealing with square roots because there's no number there. So there's an invisible 2. Now we already have one of these numbers under the radical sign. They give it to us. They give us this 3 here. So I'm just going to write the square root of 3 here. But we need to write 4 under a radical sign, but it has to be equivalent to 4. So what number would we put under that radical sign? Well, the square root of 16 is equal to 4. So that's how we would write that number there. So we have the square root of 16 times the square root of 3. And now we can use the reverse rule for the multiplication property, and we're going to write both of these numbers under the radical sign. We're going to do 16 times 3 under one big radical sign. And if we multiply those out, 16 times 3 is equal to 48. So there's the entire radical of 4 root 3. It is the square root of 48. So the toughest part about these questions is figuring out this number here under the radical sign. So you need to think to yourself, the square root of what is going to get me 4? So in this case, the square root of 16 gave us 4. Now let's look at B. This time we're dealing with cube roots. So our first step is to write two numbers under the cube root sign. They already gave us one of them, the 2. So I'm just going to put 2 over here. But we need to think, the cube root of what number gives us 3? Well, the cube root of 27 gives us 3. So now what we can do is write both of those numbers under one big sign. So 27 times 2. And if we multiplied those two together, we would get the cube root of 54 as our final entire radical. And finally, let's try a fifth root. So to start off, let's do two little fifth root signs here. We already have one of them. We have the fifth root of 2, which we're going to put in this one over here. But we need to think, the fifth root of what number gives us 2? So one way you can figure that out is you could do 2 times 2 times 2 times 2 times 2. And if we multiply 2 by itself 5 times, we get 32. So then we know the fifth root of 32 is equal to 2. So that's the number we're going to put under this first radical sign here. We're going to put 32. So now we have the fifth root of 32 times the fifth root of 2. Remember, there's like an invisible dot always in between those two, or visible multiplication symbol. So now we can write both of these under one sign. 32 times 2 under that fifth root sign. And finally, our final answer would be the fifth root of, well, 32 times 2 is 64. So there's our final answer for this one. Now our final example here, example 5. Arrange the following from greatest to least without using a calculator. So the easiest way for us to do this is to convert all of them into entire radicals. If we convert them all to entire radicals, it'll be very easy for us to compare each of them to one another. So let's start off with 3 root 5. So I'm going to put 3 root 5 over here. And if we were to convert that into an entire radical, we would think the square root of what is equal to 3. So square root of 9 would be equal to 3. Therefore, we would write this as 9 times 5 is 45. So the square root of 45. Now let's try the next one here. We got 2 root 13. So then we would have the square root of 4, because the square root of 4 is equal to 2, times the square root of 13. And then if we do 4 times 13 in our heads, we get 52. Next one, we have 4 times the square root of 3. So we have 4 square root of 3. So then square root of what number would give us 4? Well, that would be 16. So square root of 16 times the square root of 3. And if we multiply 16 times 3, we get 48. Then we just have the number 2 here. That one's a little tricky. How would we write the number 2 as an entire radical? Well, the square root of what would give us 2? That would just be the square root of 4. So we'll leave it at that. And finally, we have 9 times the root of 2. So the square root of what would give us 9? That would be the square root of 81. And then times root 2 beside it. And 81 times 2 gives us 162. So let's look at all these final answers we have here. We have square root of 45, square root of 52, square root of 48, square root of 4, and the square root of 162. So now it's really easy for us to see which one's bigger and which one's smaller. So if we're doing greatest to least, the greatest one would be the square root of 162. Then next we would have the square root of 52. Then we would have the square root of 48, square root of 45, and finally the square root of 4 at the very end. So when we're listing our answer here, we want to use the original questions given. We want to use these numbers here. So let's put a little side note. Write answer with original radicals. And I'll point to these ones here. So if we're writing from greatest to least, the first one's this one down here, and the original radical would be 9 root 2. So I'm going to put that first, 9 root 2. Then the second one would be this 2 root 13. Then next we would have the 4 root 3 right underneath it. And fourth we have 3 root 5 at the top here, so 3 root 5. And then finally we would just have that 2 at the very end. So here's the final answer for this question.